How do aircraft carriers refuel in the middle of the ocean? Far out in the open ocean, where the horizon blurs into endless blue, U.S. Navy aircraft carriers thrive as self-contained cities, teeming with activity and purpose. But how do these massive vessels, housing thousands of crew and an entire fleet of jet fighters, stay operational for months at a time without returning to shore? The answer lies in a combination of advanced technology, seamless teamwork, and daring at-sea maneuvers. From nuclear-powered endurance to refueling in the most challenging conditions, every detail showcases the ingenuity that defines modern naval operations. How long can these titans roam the seas, and what happens when they need to refuel with no port in sight? Aircraft carrier operations and fuel needs. Aircraft carriers are engineering marvels, designed to serve as mobile command centers and air bases in the middle of the ocean. On board, over 5,000 crew members carry out critical tasks to keep the ship running. These include managing flight operations, maintaining intricate onboard systems, and supporting the daily needs of the crew. But have you ever wondered what it takes to keep these floating cities powered and operational? Day after day, mission after mission. The answer lies in an incredible blend of technology, strategy, and relentless coordination. The demands placed on an aircraft carrier are staggering. The propulsion systems ensure the ship can traverse thousands of miles, while advanced radar and communication systems provide situational awareness across vast areas. On the flight deck, jets burn through aviation fuel as they launch into the skies. And deep below deck, the crew requires a steady stream of food and supplies to sustain operations. Every detail matters, and every system must work in harmony. Without a reliable supply chain, the entire operation could come to a standstill. Consider the power of nuclear reactors used by carriers like the Nimitz and Ford classes. They generate energy for decades, allowing the ship to travel the globe without refueling its core systems. Yet even these giants require aviation fuel, provisions, and equipment to maintain their edge. Conventional carriers, powered by diesel engines, face an even more pressing challenge, requiring frequent refueling to stay in the fight. This raises the question, how does the Navy ensure these vessels get what they need when ports are thousands of miles away? Every day at sea is a delicate balance of preparation and precision. From powering the engines to launching aircraft, everything hinges on the Navy's ability to replenish supplies. How is this achieved under the constant threat of weather, operational demands, and potential adversaries? It's a process as impressive as the carriers themselves, and one that reveals the incredible ingenuity behind modern naval strategy. Refueling methods at sea. Refueling a U.S. Navy aircraft carrier in the middle of the ocean is no small task. It's a high-stakes operation where precision and teamwork meet state-of-the-art technology. Known as Replenishment at Sea, or R.A.S., this process allows a carrier to receive the fuel it needs without ever stopping its mission. But how does it actually work? The answer lies in a carefully choreographed sequence of actions that showcase both engineering ingenuity and human skill. The operation begins long before the supply ship and carrier ever meet. A specialized supply ship, like the John Lewis-class Replenishment oiler, approaches the carrier and carefully aligns itself parallel at a distance of roughly 100 to 160 feet. Both vessels match their speed, typically cruising between 12 and 16 knots to maintain stability. This might sound straightforward, but keeping two massive ships perfectly synchronized in open water is anything but. Weather, waves, and even the occasional rogue current threaten to disrupt the delicate balance. Once the vessels are in position, the connection process begins. A shot line, a lightweight rope propelled by a rifle or launcher, is fired from the supply ship to the carrier. This line pulls across a heavier messenger line, which in turn is used to haul over the main fueling hose. Supported by tensioned wire ropes and pulleys in a system called the Standard Tensioned Replenishment Alongside Method, the hose remains elevated above the water, accommodating the natural motion of the ships. It's an impressive feat of engineering, designed to ensure the hose stays secure no matter how the waves rise or fall. As the fuel transfer starts, powerful pumps aboard the supply ship send thousands of gallons of fuel per minute through the hose. Crew members monitor every aspect of the operation, from the pressure gauges to the tension on the cables, ensuring the process runs smoothly. Safety protocols are followed meticulously. See breakaway systems ready to disconnect the ships quickly if conditions suddenly deteriorate. The process may last several hours, but every second showcases the unparalleled skill and coordination of the Navy's sailors. Despite its complexity, R.A.S. isn't immune to challenges. Waves can become unpredictable. To counter these risks, the Navy relies on constant communication. Teams on both ships use radios, hand signals, and visual markers to stay in sync, making sure that every command is understood and executed without delay. It's a process that embodies both precision and adaptability. With each successful refueling, the carrier extends its reach, allowing it to continue operations without interruption. But when difficulties like rough water or adversarial threats intensify, how does the Navy respond? That's where the ingenuity and resilience of its sailors come into play, ensuring the mission is always accomplished. Nuclear-powered aircraft carriers, redefining endurance. Nuclear-powered aircraft carriers are a revolutionary achievement in naval technology, designed to stay operational for extended periods without needing to refuel. Unlike their conventionally powered counterparts, which rely on massive diesel engines and require frequent refueling, these carriers are powered by onboard nuclear reactors, capable of producing energy for decades. But how does this revolutionary design impact their ability to stay at sea? At the heart of these carriers, like the Nimitz and Ford classes, are powerful nuclear reactors that provide a virtually limitless energy supply for propulsion and onboard systems. These reactors allow the ship to traverse thousands of miles without needing to stop, a capability that transforms how naval missions are planned and executed. With this technology, the carrier itself becomes a self-sustaining hub, free from the frequent refueling cycles required by conventionally powered ships. However, while the reactors eliminate the need for traditional refueling, they don't solve every logistical need. The jets aboard the carrier require vast amounts of aviation fuel, and the ship's crew needs a continuous supply of food, water, and other essentials. These demands ensure that even nuclear-powered carriers depend on regular replenishment operations to maintain full readiness. Without these supplies, the carrier's operational capabilities would be significantly diminished. Nuclear power also introduces its own unique challenges. The reactors require rigorous maintenance to ensure safe and efficient operation. Specialized crews oversee reactor performance, conducting detailed checks and repairs as needed. The complexity of the technology requires specialized training for the crews who manage it, ensuring they can quickly and effectively address any potential issues. Operating a nuclear-powered carrier is like managing a living organism, where every system must function in perfect balance. Propulsion, onboard operations, and emergency reserves all draw from the same source, requiring crews to carefully allocate energy with precision. But what does it take to coordinate the resupply of aviation fuel, provisions, and other necessities for such a massive operation? That's where the ingenuity of the Navy's logistics teams comes into play, ensuring that every mission stays on course. Factors limiting time at sea without refueling. Even with advanced technology and nuclear-powered propulsion, no aircraft carrier can remain at sea indefinitely. While nuclear reactors provide a virtually limitless energy source for propulsion and onboard systems, other critical factors ultimately determine how long these ships can stay operational without support. Aviation fuel is one of the most significant constraints. The jets aboard an aircraft carrier are essential to its mission, but their high fuel consumption creates a constant need for replenishment. Each jet launch consumes a substantial amount of fuel, and during intensive flight operations, an aircraft carrier can consume between 10,000 to 20,000 gallons of fuel per day. With fuel capacities ranging from 3 to 5 million gallons, carriers can sustain flight operations for extended periods. However, Without regular replenishment, the carrier's air operations, the core of its strategic purpose, would come to a standstill. Provisions for the crew also play a major role. With over 5,000 people aboard, an aircraft carrier typically carries enough food, water, and medical supplies to last about 90 days without resupply. However, this timeline depends heavily on the intensity of the mission and the efficiency of onboard conservation efforts. During Operation Enduring Freedom, for example, the USS Theodore Roosevelt remained underway for 159 consecutive days without visiting a port. A record-breaking demonstration of logistical coordination and crew resilience. Maintenance is another key factor. The harsh conditions of the open ocean put constant strain on the ship's systems and its personnel. Equipment requires regular upkeep to remain operational, and while many repairs can be handled at sea, more significant overhauls often necessitate returning to port. Additionally, finally, the specific demands of a mission can also dictate how long a carrier remains at sea. Combat operations, humanitarian missions, or joint exercises may require rapid redeployment or resupply to adapt to changing conditions. Balancing these demands with the carrier's endurance is a hallmark of Navy strategy and planning. How does this intricate system of resupply and coordination ensure these floating fortresses remain mission-ready? That's where the ingenuity of the Navy's support teams comes into play. Logistical support and supply chains. The success of any aircraft carrier mission depends on the intricate logistical network that keeps it supplied and operational. A carrier consumes nearly 1 million gallons of fuel every 10 days and requires constant resupply of food, water, and spare parts. This is where supply ships like the John Lewis-class Replenishment oilers come in. These vessels carry up to 6.5 million gallons of fuel and enough provisions to serve 18,000 meals a day. Resupply missions are precision operations. Supply ships follow pre-planned routes, often rendezvousing hundreds of miles from land to deliver fuel and supplies. Joint exercises with allied forces often bolster these efforts, enhancing efficiency and fostering global partnerships. However, supply ships operating in high-risk areas, such as the South China Sea, must navigate both environmental hazards and adversarial surveillance. Each successful transfer reflects the resilience and ingenuity of Navy logistics teams, ensuring carriers remain mission-ready wherever they are needed. The intricate logistical network is the backbone of the Navy's ability to project power globally. From delivering millions of gallons of fuel to sustaining thousands of crew members, every resupply mission ensures carriers remain operational and ready for any conditions. Without this seamless coordination, even the most advanced ships would fall short of their potential. Aircraft carriers are more than just naval vessels. They are mobile powerhouses that redefine what's possible at sea. Their ability to stay operational for months, thanks to advanced refueling methods and meticulous logistical coordination, ensures they remain a cornerstone of modern naval strategy. As global challenges evolve, the innovation and expertise that sustain these giants will continue to drive the Navy's ability to protect and project strength across the world's oceans.